Infinite Regress, Recursion in Mathematics and Nature. One book, one thought experiment. I'm Dawn. Every week, we'll spend 10 minutes exploring a thought-provoking book, spanning psychology, technology, philosophy, and cognitive science. Today, we explore recursion, the mathematical principle where things contain copies of themselves, creating infinite complexity from simple rules. The mathematics of self-similarity. Recursion defines objects that contain smaller copies of themselves at every scale, known as fractals. The most famous example is the Mandelbrot set, discovered by Mandelbrot in 1980. Defined by the simple formula Z plus C, this mathematical object exhibits infinite complexity. Zooming into its boundary reveals miniature Mandelbrot sets nested within the larger structure, an infinite hall of mirrors. Mandelbrot recognized fractals describe many natural structures previously considered irregular: coastlines, mountain ranges, cloud formations. The key insight is fractal dimension, a measure of how completely a fractal fills space. Unlike classical geometry's integer dimensions, fractal dimensions can be fractional. The coast snowflake has a dimension of log 4, log 3 approximately equals 1.26. The coastline of Britain has a dimension of approximately 1.25. This fractional dimension explains the coastline paradox. A coastline's length increases without bound as measuring units shrink, revealing ever finer recursive details. Recursion in biology. Nature's greatest masterpiece is DNA replication, a recursive process of self-copying. The double helix unwinds, and each strand serves as a template for a new complementary strand. This process involves multiple recursive feedback loops. DNA helicase unwinds the double helix. DNA polymerase copies each strand while proofreading its work. Hexanuclease enzymes correct errors in a recursive feedback loop. This elegant recursion ensures the accuracy, approximately 1 error per billion nucleotides copied. On a larger scale, plant growth follows recursive algorithms. Trees branch according to recursive patterns that maximize sunlight capture. Romanesco broccoli exhibits perfect fractal structure, with each bud containing smaller copies of the entire vegetable. Nature's recursive artistry. The human lung's bronchial tree branches recursively 23 times, transitioning from trachea to bronchi to bronchioles. This recursive architecture packs a surface area equivalent to a tennis court within the confines of the thoracic cavity, a marvel of biological engineering. Recursion in technology. Computer science has wholeheartedly adopted recursion as a fundamental programming paradigm. Recursive algorithms solve complex problems by breaking them into smaller subproblems of the same type. QuickSort recursively splits arrays and sorts subarrays. Fibonacci sequence. Defined recursively as fn equals fn1 plus fn2. Tree traversals navigate hierarchical data structures through self-reference. The most ambitious recursive computing project is DeepMind's Recursive Intelligence Project, which aims to build AI that improves its own architecture. In 2024, their system modified its code to solve problems 23% more efficiently, a step toward Hofstadter's vision of self-referential artificial intelligence. Recursion raises profound questions about infinity and complexity emerging from simplicity, a theme Hofstadter weaves throughout his masterpiece as the eternal golden braid, connecting mathematics, art, and consciousness. Reading is a gentle way to have a conversation with the world. Thank you for listening. I'm Dawn. May every book we fast read bring a spark of mental awakening. See you next week.